table, and you can take the value of -2. That is the x value that you want to plot in the middle of your table. Can I just arbitrarily pick x values when I have a parabola? No, because I want to find x values that are around the vertex, which is why my x value of the vertex goes in the middle of my table, because I'll write values above and below it, around it, and my graph should become a parabola in the shape very similar to the one that we drew using our transformation. Some questions about that? Casey?
The 2 squared, so would that make it 4?
No, not necessarily, because it is in the form x minus h parentheses squared. So my h represents the x value of my vertex, so it doesn't change it to 4. The value of h is just -2. We've talked about this already, but now it's official. The value of a tells you whether or not the parabola opens upwards or downwards, and it also tells you whether the graph is narrower or wider. And we talked about how when the value for a gets larger, the graph is narrower. And you could probably remember too that when we discussed this, whoa, not where I was going. Yeah, when we discussed this, we also said the reason why that works. It's a little time. Oh, there it is. I was going to do all that on here. Okay. So when a equals 1, move everything around. There's the parabola that we just previously sketched using transformations. If I change the value for a and I make it wider, make it larger, it is going to make the graph of my parabola skinny. The way you can remember that is if you go the other way, if you make a closer and closer to 0, it's going to start looking more and more linear. Because remember, when a is 0, a quadratic is in fact a straight line. Because if you're in the form y equals ax squared plus bx plus c, if a is 0, the x squared goes away, which makes it linear. So if you're at a value of 1 for a, the closer you get to 0, the wider it gets, because it gets closer and closer to being a line. And I can't make it exactly equal 0, but when it does, it's just a straight line. This side of the parabola ends up just shaping around like this, curving around to become linear. In fact, if I do that, I can do this. If I do a equals 0, now it's a line. No, because it kept turning it as well. It rotates it around as well. Wish I could erase this on here. Oh, I can. Oh, I can't. It doesn't matter. There is, but I didn't feel like pushing it. So it's hard to be up here. They know. It's hard. Well, I'm learning too. Technology is like changing faster than I can learn it. Here are some different transformations that the book is telling you about at this point. We started talking about this like way at the beginning because it was so helpful. But they're telling you all kinds of stuff here that you already know because we've already discussed it. When the value for k changes, it affects how far you move it up or down. The value for h affects how far you move it left or right. It's opposite of what you think. And then the direction of opening. If a is positive, it opens up. If it's negative, it opens down. And the value for a affects whether or not I'm getting wider or narrower. And that's the absolute value for a. So if it's a -2, that means it opens it downwards, but it's still like a 2 in that it narrows it down. Okay, now, the fun part. we could take any function that is in standard form of a parabola and change it so that it becomes vertex form. So we can do that. How do we do that? Well, if it's in standard form, if I have y equals x squared plus 8x minus 5, I want to change this so that it gets into vertex form, which is the y equals a times parentheses x minus h all squared plus k. Well, how to do that is you're going to complete the square. Ta-da. So here's the trick though. When you complete the square, notice that the other value of the equation, the other side of the equation has a value of y, not 0. So I can't just like add things to both sides of the equation anymore. It just doesn't work because there's a y over here and I want to keep the y alone. So when we go through the process of doing this, we'll say x squared plus 8x, and then usually, remember we write in a blank, plus blank, and then we would move the 5 to the other side. We're going to have to keep the 5 on this side, so it's going to stay negative 5. But now whatever I add to the right side of the equation, I also have to subtract from the right side of the equation. Because what I add, this magic number that I'm going to add, I'm also going to have to subtract so that I'm really adding 0. The reason I put the blank in here is because I want to complete the square, right? I need a number that is a perfect square. What number is that? Well, you take the b value, cut it in half, and you square it. So what is half of 8? 4, so this is going to become x plus 4, all squared. And then 16 is what's going to go in the blank. Now when I add 16 in the first blank, I subtract 16 in the second one. So did you notice that when I wrote the blanks down, I automatically put this minus sign in the front of it and the plus sign in front of this one? That always occurs, so you can get used to writing plus and then minus. What you add, this number is always going to be positive, because even if this number is negative, it gets squared. It's positive, which means this one's always going to have to be negative. Now why did I write a plus 16 and a minus 16? Because really, how much am I adding to the right side of the equation? What is the net value of these two? Yes, plus 0. Which means I haven't broken any laws. Right? All my algebra rules still work. If I added 16 to the right side, I would also have to add it to the left. Because what you add to one side, you add to another. But if I add nothing to the right side, I can add nothing to the left, which is what I wanted to do, because I wanted to keep it like that. So now this is x plus 4 parentheses squared. What is that? That took all this information up here and allowed me to complete the square with those values. And now I still have left, what? Negative 21, which I'm going to have to write after this. And now I've actually written this in vertex form. This is in the form y equals a times x plus 4, x minus h, parentheses squared, plus k. What is my vertex? My vertex is negative 4, that's positive 4, keep the opposite, negative 21. No, it's still plus k, Xander, not negative. So it'll be negative 21, the y value of my vertex. What is the a value? It's 1. Yeah, great question. We're going there. Any questions about this? Should I take you through it again from the beginning? Because sometimes it's hard to write and listen at the same time. I get that. I can't do that. So let's do a quick recourse. So we start at the beginning. I have y equals x squared plus 8x minus 5. And I said, okay, I'm going to complete the square. I'm going to add blanks. I can't add blanks to both sides of the equation because there's a y equals on one side. So that I'm going to add one blank after the 8x, and then I'm going to subtract whatever's in that blank on the same side of the equation at the end. So that I'm really adding 0. And then I can complete the square with x squared plus 8x plus 16 to get x plus 4 parentheses squared. Negative 5 minus 16 is negative 21. That's in vertex form. Okay. So now, let's do one without an a value of 1. And then we'll have you try one. Would you like to try one before you change the a value? Okay, we'll do that. It's probably good practice anyway, and we have time. So why don't you complete the square and write y equals x squared plus 2x plus 4 in vertex 1. So for example 3, I have an a value that is -3. So normally if there was a 0 on the other side of the equation, what would we do? Divide everything by -3. I still need to come up with a way to do that, but I don't actually want to affect y. So how you would accomplish this is you would factor it out. So this -3 is going to get factored out. And then the only thing I want to factor on the inside is the -3x squared plus 6x. If I factor out a -3, that makes this positive x squared. -3 times x squared would be -3x squared. Right? And what does it do to this plus 6? -2. If you take 6x and divide it by -3, -2 x. And then after that, I've got a -1. Now I'm going to write my blanks in here. So this is y equals -3 times parentheses x squared minus 2x. Now the first blank, Waverly? Because then it would be hard for me to complete the square. So the GCF here is -3x, but I'm completing the square, so I want to keep the x squared inside for now. So I'm not necessarily pulling out the greatest common factor, I'm just pulling out the -3, because I want the a to become 1, which I'm doing in effect by factoring out a -3. And now inside my parentheses, that's where I want the first blank to go. And then outside my parentheses, where there's a -1, that's where I also write my negative blank. Sorry, my blanks are a little non-horizontal, but here they are. Blank, blank. Now, what number needs to go in the blanks? So I take the b value, I cut it in half, and I square it. So half of -2, -1, -1 times -1 is a positive 1. So there's a +1 that goes in the first blank. Do we agree with that? Now here comes the challenge and the trick that many students miss. When you add the 1 inside the parentheses, what are you really adding to this side of the equation? -3 times 1, which would be -3. So when I add this 1 here, what I'm really adding is -3 times 1, which is -3. So what needs to go in this blank over here to make it 0? +3. So just to run that by you one more time. I figured out that there's a 1 that goes in this blank, because that's half of b squared. So that's -1, half of -2, right? When I square it, it becomes +1. When I write the 1 in this blank, I'm not really adding 1. I'm really adding 1 times -3, which is -3. So since I'm adding -3 here, I want a net effect of 0. I need to add 3 to the same side of the equation to really add 0. And then you go on. Now I can factor this stuff. So this stays as y equals -3, and then times parentheses. Half of -2 was -1. So this is x minus 1 parentheses squared. And then the -1 plus 3 makes +2. what is the value of my vertex? Negative 1, 2. Positive 1, 2. Sorry. How did I get what? Negative 1 plus 3 gives me 2. X minus h. H is positive 1. So 1 comma 2 is my vertex. What does this negative 3 do? Makes it open down, and the 3 makes it narrower or wider? It's going to make it narrower. Yes. Okay, questions? I think I have one for you to try or something. Yeah. There you go.
Is this thing supposed to be in the vertical?